had a negative sign in your terms, it means you're subtracting your factors that you get. And that's a little bit counterintuitive for most people. So we're going to deal a different problem, and this is from 4.8 in your handout. So handout 4, problem number 8. Let's go for it. We see that the last sign is plus. So we're in the plus factor scenario when we get these together. We also find that, okay, we have a simple factor over here. 1 and 5 are the only factors. Over here we have 1 and 26, and then 26 can be factored into 2 and 13. Okay? So if we had to list out our little boxes, we need 1 and 5 plus and minus versions of each. The minus don't count because we have a plus sign here and there, so we know we need the plus terms. And then over here we've got 1 and 26, and I'm not going to do the plus and minuses since we already know we need the positive version. And that's our little factor set for each of those. Okay, given a combination of these numbers, like 1 times 1 and 5 times 26, or 1 times 26 and 5 times 1, or 5 times 2 and 1 times 13, or the reverse of that, there's going to be some combination that adds up into this magic number right here, the 23. I like to take it down right by my factors, here and here, and write it just so I know that's what I'm trying to sum to. So let's pick numbers that would work to add to 13. 1 and 5 is going to be an option. If I multiply 5 times 26, that's going to get a bigger number, so I probably need to be dealing with this set right here. So let's say it's 5 times 2, and then 1 times 13. Well, 5 times 2, that's 10. 1 times 13, oh, hold on, what did I do? 1 times 13. Yeah, so 1 times 13 is 13, 10 plus 13 is 23. We have found our factors, so we know that we need the 1 and the 5 option, and we need the 2 and the 13 option. Whatever the last factor tree was is going to contribute this number right there and this number right there. So we can write it right here, 2 and 13. We know that both of these are going to have an x term, and we just have to figure out the order that makes this thing happen, the 5 times the 2. Well, there's the 2. So 2 times that one and then 2 times that one. So this one right here needs to be the 5. We established that over here. And this one over here needs to be the 1. So it's 1 times 13. 1 times 13, 2 times 5, that's 10 plus 13. Now we check the whole thing. X times 5x is 5x squared. X times 13 is the 13x. 2 times 5x is 10x. And then 2 times 13 is, well, not 2 times 13, 2 times 5x. Oh yeah, 2 times 13 is 26. Sorry, I got lost there. So we have, in fact, actually gone through that trinomial. The last problem, in case you can still stand it, is this 15x squared minus 34x minus 16. Let me write it on a new page. So 15x squared minus 34x minus 16. And this is from handout number 4, problem number 13. Okay, so we see the thing we didn't want to see, the minus sign there. So we need a difference. We don't add the two numbers, we subtract the two numbers in the end. We see 15 at the beginning. That's 1 and 15. That's also 3 and 5 for factors. Those are the only factors. Over here we see 16. You'll notice I didn't do the tree over here, but I'm going to warn you against that because sometimes you'll forget factors. If I just thought it was 1 and 16 and 4 and 4 and that's it, I would have forgotten what I would have found if I had actually factor treed it. So that would be 1, 16, 2, and 8. 8 is 2 and 4 is 2 and 2. So in groups of two factors, I have 4 times 4, I also have 2 times 8 and 1 times 16. So I forgot the 2 times 8 there. All right, now let's do the hardship of trying to get these numbers to subtract to 34. It's the important number, we put it right here. We can make the sign on one of the numbers negative and the other positive to make the negative 34 happen. We just need to care about subtracting them in the beginning. Okay, this could actually be slightly problematic. This is probably a fairly tough problem. There's no easy way to do it other than trial and error will tell you that, hey, if I got a big number in the middle, I'm not going to have 1 times 16 and 15 times 1, because when I subtract those numbers, I get a really small number like negative 1. I don't really want that. So I'm going to probably lock into this set from that first one. And I really don't know offhand which of these are going to work, though this is probably not very likely. I've learned that from experience, but you might just have to work all 3 sets. So the thing to do is combine these numbers in different orders. So one option would be 3 times 1 plus, minus, actually you should say plus or minus because either one of them could have been negative. So 3 times 1 and 5 times 16, that's an option. Another option is 3 times 4. There's the plus and minus. Another one would be 5 times 4. So one from that one from that one. Another option we have is 3 times 2, that's 6, and 5 times 8. 5 times 8 is actually 40. I found, just because I was doing the math in my head a little bit, that this is the right one. It might take you actually working all the numbers out and adding them together. But you'll see, if I make this number 40, that number 6, and I make this one the minus and that the plus one, minus 6 plus 40 does in fact equal 34. Oh, but I realize it's negative 34, so I'm going to switch the signs. That's the plus, and now that's the minus. So this is now negative 34. So my factors here for this problem, which is very difficult, both are opposite signs because there's a minus. There's a plus and a minus, and I can draw it any order I want. But I do know that the 8 needs to be negative, and the 5 needs to be multiplied times it. So if I put the 5 at the beginning and call that 5x, and call that other one 3x, and notice how I put the ones that came from the x term at the beginning, the x squared term, first. That helps me actually just remember to put them first here. That can be helpful. So 5x times 3x is 15x squared. We got that term right. And then the 5x times negative 8 is negative 40x. And I just need to manufacture the remaining part, which would be, the 2 right here. So 2 times 3 is 6x. 6x minus 40x does in fact equal negative 34x, which is what we wanted to see. That's the end of this video. Thanks.